Okay, great. Yeah, thank you so much, Stefan, for inviting me here. And it's nice to talk to you all, see all these names here that look like you're all over the world. Um, yeah, can I share my screen, Stefan?
Yes, you should be
Okay,
able to.
great. So I'm going to share my screen here. And so I've taken a couple extended trips throughout India to look at what I consider the largest scale water harvesting aquifer restoration projects on the planet, basically from my investigations. I'm actually about to go back to India for a third time and do another video series this winter as well. And so there'll be more happening. This is actually a picture from Rajasthan. Um, and just if you want to learn more and see more details, I'm just going to give you a really quick little snippet of some of these projects here. But this is the video series that I produce. It's called India's Water Revolution, and it's there on my YouTube channel. And part of what I'm trying to do is tell a story to people. Like I just heard the last conversation about whether people are receptive to science and numbers or not. And I've kind of determined that the best way, at least using my talents, to increase, receptivity among people is to do it in an entertaining way, like edutainment, so storytelling to get people inspired to actually inspired to action. So we'll just start by reminding ourselves of the precipitation map of India right here. We can see, India is a monsoonal climate. We can see there's very arid areas, especially up in the northeast and also in the center of the country. So some of the sites that I'm going to show you here are in those most arid areas of the country. And we'll start in the state of Maharashtra. So when I go back to the precipitation map for a second, you can see that parts of Maharashtra are in the dark red color, which is between 300 and 600 millimeters per year. And so that's the area that I'm going to show you this one particular village in. And the Pani Foundation is an organization that's it was founded by a very famous Bollywood star, Amir Khan. And so it has a huge amount of public support because it has a very big celebrity at its helm. And like, again, if you watch the videos, I kind of tell the story a little bit and you can learn a little bit more about him. But they did a contest between villages called the it's in the way, the Satyamev Jayate Water Cup competition, where between 2016 and 2019, so they held this particular part of the competition for 4 years, and they had about 10,000 villages compete. And the idea is to see which village can build the most amount of water harvesting structures in a 45-day period. So they pit villages against villages, but it's a contest where there's really no losers, because if you participate, then you're increasing the water capacity of your village. And so the impact they list in those 4 years is that the amount of liters of water storage they created through their contest was 55,000 crore. Now, a crore is 10 million liters, right? Or 1 crore equals 10 million. So 55,000 crore equals 5.5 trillion liters. So that's how many liters of water storage they are claiming that they created in these 10,000 villages that participated in their contests, right? So very impressive here. And so for one of the videos that I did, I visited one of the villages that actually won the water cup competition. So they beat out hundreds or thousands of other villages. And so I wanted to see, what is the scale that it takes to do this? Like, what does this actually look like on the ground? So this is the village of Velu. And the really advantageous thing about these villages is that the village lands that they control are roughly divided by watershed boundaries. So each village has its own little watershed sub-basin that it's controlling. So when a village goes and they get together to restore their common lands, they actually are working within the hydrologic unit of a watershed. So this watershed, so this is like a typical village, the one that they have about a, little over 6 square miles watershed, or a little over 16 square kilometers watershed, that they pretty much did treatments over the entire watershed, and in a 45-day period put in enough water harvesting structures that they recharge their aquifer permanently. They've created a permanent state of recharge in their aquifer now, because every time it rains with the monsoons, they're recharging pretty much the entire basin into the aquifer. And what this means for them is that they now, instead of just growing one crop during the monsoon season, they now can grow 2 crops, which for farmers, it doubles their income basically, and creates like a permanent food security, water security, and economic security in these villages. So, just when you zoom in on Google Earth, you can see just some of the basic treatments they're doing in the watershed. You can see these horizontal lines going across. These are what they call continuous contour trenches, where they're just putting ditches on contour to intercept sheet flow down the watershed. And then this particular village actually did like they moved water across their little micro watershed subbasin. So this white line that I have in the middle here, it shows, so I have their different ponds that they had historically here, with the different subbasins of their watersheds outlined in various colors: red, blue, pink, and orange, and dark blue. And then this white line actually shows a pipeline that they put in to move water from this one pond with the largest catchment but poor infiltration over to these other subsequent ponds that were basically just for infiltration. So they move water here over and they pond it in these areas. It soaks down and recharges the aquifer. And they went from literally having a depleted aquifer where their shallow surface wells that they use for pretty much all their water needs were drying up, to now having just plentiful surface water. They've also now recharged the aquifers of the subsequent villages that are downstream from them as well. So, you start to see these really broad scale cumulative effects when you have this type of treatment at this type of scale done over 10,000 villages in a state, right? Okay, so now we're going to jump over to West Bengal real quick, and I'll just try to be as fast as I can here. And this is over, it's in the eastern part of the state, bordering Bangladesh there. And you can see this is a higher rainfall area, between 1,200 and 1,500 millimeters per year. But the area that we went to is actually a little more on the arid side, on the 900 to 1,200. And so this is in the Ganges River Basin, which, as many people probably know, is, feeds hundreds of millions of people, or gaining their sustenance within this watershed basin. And the organization I visited there was called DRCSC. And it is like a Gandhian-based organization that works with the most marginalized populations, basically poor tribal communities that are located at a marginal place in the landscape because of their water resources and their soil. So we visited a number of ponds that were hand dug by villagers, mostly women. And the really fascinating thing about these ponds is the design that they did. So you can see this group of women and girls are standing there, and you can see these gardens below. They have little rows of crops that they've been put in. These are actually terraces of the ponds that, as the pond level drops, cultivation terraces are revealed. And because of the relationship between the ponds and the terraces are actually sub-irrigated by the pond water. And so we visited a number of these different ponds that, as the water level drops, these gardens are revealed. I drew this diagram to kind of explain here. They cultivate the entire surface of the pond as the water level changes. So in the monsoons, the water levels all the way up to where I have the woman standing there, and then it drops down, revealing the terraces, and also provides access for cattle to drink. They even cultivate the berms of this pond. This is a image here of, this is a cultivated berm here, and this is the group of villagers standing on the top of the berm, and then you can see down below the fields of this is chickpea and mustard. Those are sub-irrigated because the water from the pond, then it's not a really aligned pond, it's just hand dug. So the water actually seeps down and creates this lens of sub-irrigated agricultural land down below. And it's completely changed the fortunes of these people who spent much of the year leaving their area and going for very low-paying migratory work, right? So last one I'll show you real quick, I just have a couple more minutes, is in the state of Telangana. Again, when we look at the rainfall map, you can see in that state there that we're in a low rainfall area between 3 and 900 millimeters per year. And this is a very famous permaculture farm, the oldest one in India that's like has the name permaculture basically. And this is Aranya Farm, and it was built on a laterite plateau of bedrock. So really, what's considered by the Indian government a wasteland. And this is a picture of the farm there. It's the only agricultural land up there. Otherwise, it's very low value eucalyptus timber. And this farm basically did different water harvesting methods by excavating the bedrock and creating basins to collect the runoff over this bedrock area, planting the mounds, the buns in this situation here. They also built contour swales that would collect the monsoon rains, and then planted the buns with fruit trees and other species. And then, on real bedrock areas, they'd find little places where soil was collecting, and then they would excavate out there, plant here. They planted a mango tree and some vegetables around, and they would start to create like a little center where water's starting to be harvested, and then they would increase their planting area out from there concentrically. And over the decades that they did this on this bare bedrock area, they basically have succeeded in creating this absolutely spectacular, it's about an 11-acre food forest, huge biodiversity, lots of food production. They also have annual agriculture in there. So they've taken some of the just most devastated wastelands and turned it into this really highly productive, as well as all the other benefits of habitat, timber, etc. So those are my slides, and I left about a little bit of time for questions here as well. And again, this is India's Water Revolution, is where you can see a lot more of the details of these projects. So I will leave it there, and I will leave my full screen.
Yeah, thank you very much, Andrew, for these impressions. Yeah, I posted your channel, YouTube channel, because I mean it's really worthwhile looking at it. What do you think about upscaling these projects? I mean, there are more and more projects like these that you mentioned, and others in India. Is it something that is really only minor in number and scale, or do you see a trend, eventually even an exponential trend in implementation?
Yeah, I think that there's a trend, because these are only there's more projects I could show if I had more time as well. Some of the ones I'm going to visit when I go this winter, up in Rajasthan, I don't know if Dr. Rajendra Singh, basically he's brought 7 rivers that had dried up and only became monsoonal drains when it was raining. He's turned them back into perennially flowing rivers. So, I mean, yeah, India is a vast landscape and there's vast land degradation, but the projects that are really doing well are really, like, at this point, at the scale that you can pretty much see them from space. I mean, you can see the effects just through the coloration when you look on Google Earth, if you look at the area, So, I mean, I think it's a trend. And also, of course, extreme weather events are also a trend there as well. So,
And would you say that these approaches are probably mostly or mainly bottom-up approaches? So it's really engaged citizens changing something, and how much of this lands or finishes at the end on policy level as well?
Yeah, I mean, really, this is almost everything I saw was at least began in the bottom up level. Although once they gained a certain amount of success and traction with the politician, with the population, and the politicians would jump on board because, they see advantage in it, or some of them. So, I mean, the Pani Foundation, basically, you get this one organization, and I guess it's top down in the sense that you had the Bollywood star, Amir Khan as the instigator, but I mean, a competition between villages, adding the competition element into the whole mix has just really stimulated people's excitement, and so, yeah. So overall, I mean, a lot of it's like the spirit of Gandhian volunteerism, that permeates India. So I think it's like tapping into that people power and, the spirit of communal volunteerism is a really big part of it.
So my next question would have been, and is actually, and I'm laughing because you talk about the Ghanaian spirit. In the Western United States, I would say one has almost similar conditions. Meanwhile, in California, Utah, Arizona, drying landscapes, rivers drying out, etc., etc. So, do you see any chances of implementation or of implementing what is happening in India in southwestern states?
Well, the other real advantage that India has is because its villages are located ancient have been there for ancient times. Then the boundaries of the village are watersheds, are hydrologic units. And so when you look at the United States, when you look at land divisions, it's a grid, the land ordinance of 1787, which laid a geometric grid over the landscape. It means that property boundaries don't correspond to watershed boundaries. So this is like an immediate, I call it like a type 1 error. It's like an error that creates a fundamental flaw in the design from the beginning. You can't really, because the property boundaries cross randomly over ridges and valleys, and your neighbor could be deforesting their watershed while you're restoring theirs, and if they're upstream from you. So, I mean, I don't know. I've had this question a lot, and I asked this question of the director of the Pani Foundation when I recently interviewed him, and he didn't necessarily have a great answer either. I think that the spirit of volunteerism in small towns, I mean, I think that's the thing to kind of tap into. But I think that there's a real disadvantage based on property boundaries and the pattern that they fall within.
So it would be more like a top-down approach anyways than in Western.
Yeah, more of a top-down approach, working on like water supply issues, river quality issues, groundwater pollution, that kind of thing. It's almost like you'd have to have a top-down here because people in America are too fragmented and individualistic, I think, to be able to pull something off that takes this much uniting around a watershed basin.
Yes, so thank you very much, Andrew, for this really short insight. Again, if you want to see more, and you should, really visit Andrew's YouTube channel. Really fascinating videos, and perhaps, I mean, you had that Permaculture Water Summit taking place the last couple of days.
Yeah.
But you have a website with more information, and you're doing a PDC online permaculture design course. So for everybody interested.
Yeah. Yeah, if you just type in Oregon State University permaculture design, or just permaculturedesign.oregonstate.edu, you'll come to, we have non-credit courses and courses for credit. I teach on campus as well this term. And yeah, we've had an online course there since 2011. So it's with COVID, it got very big and it's remained pretty big. So we have students from all over the world. We also give a lot of scholarships out to people from disadvantaged communities as well. So if you have groups that you work with in different countries that have good internet connection, we give a lot of scholarships out for people that want to learn this work as well. Yeah.